Okay, so complex numbers. A complex number is, let's actually get to why complex numbers exist first. So if we have something squared, all that is something times itself, which in this case is going to give us 4. And, if we had 6 squared, 6 times 6 equals 36. Well, what if we had -2 squared? Well, that is still going to give us -2 times -2, which is going to give us 4. So we're always going to get a positive number, even if this number is negative. Well, this is where complex numbers come in, because never going backwards, if we say, okay, what is the square root of this? Well, all that means is, what is this number right here? What is the number squared that gives us that? So we're saying 4 equals x squared if we were setting up that problem. And we would get 2, because 2 squared equals 4. So for 36, we say, okay, what squared equals 36? Well, 36 is 6 squared. These I just kind of have them memorized. So we're going to say something x squared equals 36, which is 6. So we set this one up the same way. Well, we get 2 again. Well, that's weird because we didn't start with 2. We started with -2. And this is where complex numbers come into play. You can't take the square root of a negative number, because there aren't negative numbers that will square and give you can't go from here to a negative number. It doesn't work like that. So what we have to do is find another way to deal with these negatives. So if you try to plug in square root of -2 or square root of negative anything in your calculator, you're going to get some kind of error where it just says you can't do it. So what we do instead is we use I. And I is a complex number. And I equals the square root of -1. So by doing this, what we can do is we can split this apart into the square root of -1 and the square root of 2. And I don't really expect you guys to know how to do this exactly, but we can do this, and then we can turn it to I. Yes. Do what? I'm sorry. I will scroll back up.
Is that all you wrote?
Yes, this is all I wrote. So if we turn our square root of -1 into I, then we just have a positive square root to deal with. And this is what gives I the ability to be useful, is it gives us the ability to deal with negatives under the radical sign. Whereas, if there's a negative, we can't really do anything with it. But if there's a -1, we can just kind of pull that out, deal with it on its own, and then deal with the positive number to get it by itself or whatever. So something we need to know is if I equals the square root of -1. Is that okay? Do you need me to go back up?
No, you're good.
Okay. So if we do I squared, that's going to be the same as -1 root squared. And that's going to cancel this and this. So we are going to end up with I squared equals -1. And what happens if we do I cubed? It's going to be -1 squared. Well, we already talked about how we can't square something and get something negative, so we're just going to go ahead and get a positive number. It's going to be 1. So one more time, if we do I to the 4th, we get 1 times the square root of -1. So, which is just I. So I to the 4th is just going to give us I. Okay. So these are important things. and we are going to use them in just a minute. Mostly, we're going to use these two, or this one. So if we start working on one of the problems on the 3.01 worksheet or whatever, say we work number 4. It is 3 plus 3i negative 5 minus 2i. Okay, so it wants us to just solve this. Well, this is a FOIL problem, so we're just going to handle it just by multiplying in, and then as we get to things that we don't know how to do, I'll go over them. So if we do this, we know how to do that. It's 3 times negative 5. It's going to give us negative 15. This, 3 times negative 2i. When you're multiplying a number by something with a number and I, all you do is multiply the numbers together. You treat it just like you would an x. So you're going to end up with negative 6i. And then here, so we're in the same situation here, negative 5 times 3. So we're going to end up with negative 15 again. 3 times negative 5. And we keep our I. It just kind of stays there. And then now we do our 3i times our negative 2i. And when we have i's together, again, we just treat them like x. So we're going to multiply the numbers together, and then we're going to multiply the i's together. So we multiply the numbers, and we're going to get negative 6. And then when we multiply the i's together, we're going to get I squared. Well, we just had a definition for I squared. We had something that we could simplify it down to, negative 1. So we're going to go down here, and I'm literally just going to write this again. Actually, I'm going to duplicate it. And I'm going to substitute this I squared for negative 1. So where did you get lost?
But at first I thought we were doing, I can show you, like I thought we were doing this times this and then that times that, but then you can do this times this.
I did it in this order. I went from top to bottom on this little half moon that I drew. I did this one, then I did this one, then I did this one, then I did this one.
That's why I said I thought we were like, because it's 2 lines, so I thought we were doing this times this and that times that. So I recognize you did the bottom one that time.
You do. I just do it in a slightly different order. So FOIL is first, outer, inner, last. And I do it in this little half moon pattern. But the whole, the important part of it is that you do everything times everything else. It doesn't matter what order you do it in. So if we did this in the actual FOIL order, we would do, so first times first, so we would do this, which would give us negative 15, outer, which would give us negative 6i, inner, we would do this one, negative 15i, and then we would do last. So just going in order, now we end up with negative 6i squared, which is what we ended up with here. See what I'm saying? Okay. So after we substituted our I squared for negative 1 right here, now we just work it down and we try to get it a little simpler. So when we do that, we're just going to combine like terms. So our i's are like terms. So negative 6 minus 15 is going to give me negative 21. And now I have positive 6 here and negative 15 here. So now we can just, oh, sorry, I forgot my I right here. Now we can just, again, combine like terms. We just have two regular numbers. So 15 plus 6 is going to give me -9 minus 21i, which is going to be our answer. That's as simple as we can get this. Does that process make sense? Okay. Do what? Okay. Okay, so let's do number 2.
So the answer is
Minus 21i, yes. So if we do number 2, we do 7 plus 8i minus -6 minus 7i. And this is an easier problem. It's not a FOIL problem. All it is a subtraction. You're just subtracting that first thing from that second thing. So these parentheses are here to inform you that you're subtracting everything here. You will make it a positive, but you'll make everything on the inside a positive. So a way that we can handle this is we can make it positive and use the negative sign and kind of multiply it in. So everything on the inside changes signs. So we end up with 6 plus 7i. And they're both positive right now. Everything's positive right now, but it doesn't always have to be that way. You just have to remember to flip the signs. And now that we've done that, we can just kind of drop this. And now it is just an addition problem. And we handle it regular. So, okay, what's up? Are you talking about this one?
Yeah.
No, it doesn't go away. It just turns positive because we still have to have something there. So if we just erase it, then it's 2 problems. No, the 2 parentheses are for multiplication, and this is a subtraction problem that we're trying to turn into an addition problem because it's easier for us. Does that make sense? So the other way to do this would be if we just said we turn each of these negative and we do it step by step. Negative, -6, minus -7i, which seems a little clunky to me. You end up with 2 negatives, and then you just end up changing them to positives. So you end up with +6 plus 7i, which is what we had a minute ago, 8i, 7 plus. So with this, now all you do is combine like terms. 8 plus 7 is going to give us 15i, and 7 plus 6 is going to give us 13. 13 plus 15i. So if you have an addition sign or, an addition, am I missing a word for that? Is that just an addition sign? Okay, if you have an addition sign right there, then you don't even have to do this step here. You can just drop the parentheses immediately and pretend like they're not there. So on number 1, you could rewrite that as -7 minus 5i plus -3 minus 4i. And then you can work it down directly. You don't have to change any signs. You don't have to do anything. So I'm not going to work that one, but that's how you would set it up. So number 6, I don't really think you can do anything to it. Let me check just to be sure, though. Let me look at your lesson. Okay, so what it wants you to do is get rid of the I on the bottom. And you do that just by moving it to the top. So if you move it to the top, you want it to be it is 5/6i. So it doesn't like it on the bottom. And we can cancel i's out by multiplying by them. Because up here, we said, hey, we have a way that we can just completely get rid of an I, which this I squared is going to come in handy a lot. So what I'm going to do is just multiply by I over I, which is just 1. So if I multiply this by I over I, I'm going to get 5i, and I'm going to be left with 6i squared. And we know that I equals root negative 1, I squared equals negative 1. So if we translate this, then we're going to be left with 5i over negative 6, which is just going to make our whole fraction negative. So it's going to look like this. So it's not really a lot. They just don't like i's on the bottom. So one more time, let me look at your lesson for 9 and 10. Sure.
Yeah. What's your number?
Okay, so number 7 or number 8?
No, you don't have to.
Okay.
What is the modulus of a complex?
The modulus of a complex number, it wants you to find the conjugate of a complex number, which that's what I'm looking for in your lesson.
What's this? This is only 4. This is only number 4. This mine too.
Okay, you find the complex conjugate simply by changing the sign of the imaginary part of the complex number. So, to the modulus of it, the modulus of a complex number is the square root of the product of a complex number and its conjugate. To break this down, find the modulus of a complex number and multiply the complex number by its conjugate, and then take the square root of the answer. So let's try doing that last one. If I can find my page. There we go. Okay. So we need to find the modulus of the complex number. So we do 3 minus 5i. I think this is number 9. So to find the modular, or to find the conjugate, we switch the sign of the complex number. So it becomes 3 plus 5i. This is our number. This is our conjugate. So now we multiply them together. And we do our FOIL method. So I'm going to move it over. I'll move it back once we have an answer. Three times 3 is going to give me 9. 15. Okay, so this is going to simplify down. These are going to cancel. We end up with 9 minus 25i squared. And if you'll remember, I squared is just -1. So I'm going to substitute it out right here. So we do 9 plus 25, which is going to give me 34. And then I believe we take the square root of this to find the modulus of it. Multiply. Yep. Take the square root of this. And there, you can't really take the square root of 34. It's not a perfect square. So this is going to be your answer, the square root of 34. So our steps here to find the modulus are: first step, find the number. Second step, find the conjugate. And we do that by flipping the sign of the complex part. Then we multiply them together, and then we take the square root. So that will work on number 10 as well. Okay, let's move to 3.02. Factoring. I'm waiting on the material to open up. Okay. Let me go through your lesson, I guess. Yeah, you're good.
No, you can't use the coloring yet. Oh, wait, I think I got what you
Okay. It wants us to know perfect square trinomials, factoring trinomials, and grouping. Okay, so I'm going to start kind of differently from how your lesson starts. Hopefully that will make it a little easier to grasp. Our goal with factoring, as I mean, you guys have all done this before, is going to be to turn something like this into this. And this is useful because it's shorter, it's simpler, it's easier to work with. There's a whole heap of reasons that this is better than this. So our goal is to get from this first step down to this step, because all we know is how to get from here up to here. We just do that by the FOIL method. But going backwards is factoring. And the easiest case of factoring that you're going to have is going to be when you have 4 terms. 2x plus 2. So if you have 4 terms, you can do this process called grouping. And grouping is where you deal with the first 2 and the second 2 individually. So what we're going to do is we're going to pull anything that we can out of the first 2, and we're going to pull anything we can out of the second 2, and we're going to turn it into an addition problem. So if I pull everything that I can out of these first 2, I'm going to end up with x times x plus 2. And then I have a plus because they are added together. And maybe I pull a 2 out of these second 2 numbers. So we end up with x plus 2. So now we have 2 factored pieces, and we have to know how to deal with these. And what we do is we do this process again. We pull what we can out of both of these terms. So both of these things are something multiplied times x plus 2. So what we can do is we can just pull x plus 2 out. So when we do that, what it looks like is we write our x plus 2, and then we write what's left over. We'll go over it again. So, let's do x squared plus 8x plus 16. Okay, actually, let's not. Let's break it apart. 4x plus 4x plus 16. Okay, so this is our problem. So I'm going to underline my first 2, and then I'm going to underline my second 2. Now we break apart our first 2 numbers. We pull out what we can. So I'm looking at this and I'm saying, okay, there's an x in x squared and there's an x in 4x, but there's no number in x squared. So what I'm going to pull out is x, because that's the biggest number that I can get out. So I have an x, and I'm left with an x plus 4. That's all that's left out after I've divided all of these by x. So all I did was I took this x, I divided these by it, and I moved it to the outside. I just put it in a different spot. So now we pull out what we can out of these 2 numbers. So what I'm looking for is a number that I can pull out, because they both have numbers, and 4 seems to be a good option because 4 goes into 16. So I'm going to divide by 4, I'm going to divide by 4, and I'm going to move my 4 to the outside. I'm going to end up with x plus 4. So something you should be noticing in these problems is this and this match, and they always have to. If they don't match, you need to go back and look at it again. Okay, so now this is the step that gets most people. As we go from here and we say, okay, both of these have an x plus 4 as a term. So we're going to pull this x plus 4 out and write it on its own. And then we have, okay, well, we've taken x plus 4 out of each of these things. Well, this is what we're left with. So we end up with x plus 4, x plus 4. And they don't always have to end up with the same numbers. These are just the easiest ones to make up. So one more factoring by grouping, and then we'll do that. So there is a shorter way to go about this when you're actually given a problem, but factoring by grouping is something that you do need to know for another type of thing, and this is the easiest thing to teach it on. So if we do x squared plus, yes. Let me break apart 8x again.
Can we do that number minus something?
We can. Let me find a problem that will work like that. I can't switch the signs in my head.
I barely got the addition. I don't even mind it.
Let me work one more positive, and then we'll go ahead. Once I get through with grouping, then we'll go on to something like that. Okay, this is our problem that we're working. So I'm going to look at my first two, and I'm going to look at my second two. I'm going to pull what I can out of each. So I'm going to pull an x out of this first set, and I'm going to be left with x plus 2. And then on the second set, I'm going to pull out a 4, and I'm left with x plus 2. They match, which is good. So we write it out, x plus 2. And then we have what's left. So this is how we work this. So usually you're not going to be given 4 terms because these 2 terms are able to combine. So usually what you're going to be given is x squared plus 6x plus 8. And then you have to figure out how to get those 2 terms so you can do factoring by grouping. And how we do that is we figure out what multiplies to be this and adds to be this. So what I like to do is write this number over here. I write my last number right here. And I say, okay, let me make a list of things that multiply to be this. 1 times 8. Well, does that add to be 6? No, it doesn't. 2 times 4. Well, does that add to be 6? Yes, it does. So now we know that we can break this middle term down into this 2 and 4. And so if I do that, I'm going to be given x squared plus 2x plus 4x plus 8, which is coincidentally the exact problem that we just had right here. So I just kind of went up one step. If we go and we look at x squared plus 4x plus 4, and we go to break this down, we look at it and we say 4. Okay, well, we have 1 times 4, that doesn't add to be 4. 2 times 2 does add to be 4, so we know that we're going to break this into x plus 2, x squared plus 2x plus 2x plus 4, which is, again, the exact problem that we had right here. So all that's required to break these problems down is taking this last number and breaking down what multiplies to be it. And I start with 1, and I go to 2, and I go to 3, and I go to 4, and if it's not a whole number, I know it's not it. So I just keep going through the numbers until the number starts flipping. So when I end up with 4 times 1, then I know that it's good to stop. Okay, so if we go to work something like this, let's try to work number 3. So x squared plus 3x minus 10 equals 0. Also, an important thing for factoring is it needs to equal 0. But if it equals 0, that's just kind of a box that you have to tick. You don't really have to think about the 0. You have to set it equal to 0, and then you do your factoring process. So I'm going to write down my negative 10. And usually I just like to consider the positive because what we're looking for is some combinations of positive and negative. But if you want to write down negative, it's not wrong. You just have to think about a little more. So I'm going to start listing numbers that multiply to be 10. 1 times 10, 2 times 5. Well, now we think, okay, well, is there some combination of positive and negative for these that will give us 3? Or you can also think, how far apart are these guys? And 2 and 5 are 3 apart, which is what we're looking for. Well, we need a positive 3, so we need our little number to be negative. So now we know that we can split this apart like this. X squared minus 2x plus 5x minus 10. Okay, now we consider our first 2 and our second 2. And we break apart the x, we end up with x minus 2. And then we pull out maybe a 5.
What about this one?
It comes by multiplying those guys together.
Oh, okay.
So we pull out a 5 here. We end up with x minus 2. They match, so we're doing good. So we're going to pull it out. We're going to pull the x minus 2 out. And then whatever is left goes here. So something that you may be noticing at this point, and if you're not, I'm going to point it out to you, is these numbers and these numbers match. So if we scroll back up, so we break it apart, 2 and 4. If we get to the end, we are going to end up with 2 and 4.
So what are the factors for
The factors for what? The answer for number 3 is this. The factors are -2 and 5. And it's going to want you to work it by grouping, but you can use this trick to check yourself. And I mean, if your problem or if your teacher will accept it without you having to go through all this, then understandable. These are going to be the solutions every time, as long as there's just a 1 here. If there's another number there, this doesn't work, but I don't think y'all are going to have to worry about that with this lesson. So, okay, I am contradicting myself. So on number 5. Okay, so we look at number 5 and we have 5n squared plus 18n minus 8 equals 0. Okay, so this is a scenario that I was just talking about, where you can't just go directly to that step. You can only go to that step when this is 1. So this is clearly not 1 here. And there's nothing we can do to make it 1. So, sometimes we may be able to pull something out of this. So we could say, all right, well, if this was a 4, then we could say, okay, well, definitely a 2 comes out of this. Maybe another 2 comes out of it. Maybe we can make it simpler. But it is not. It's a 5. So there's nothing we can do with it. So the only difference between what we've been doing up to this point and this is we multiply this and this together, and we use that. So 5 times 8 is 40, and we write it over here, and we come up with factors of it. So 1 times 40, 2 times 20. So that seems to be helpful. We definitely need the 2 to be negative. We have a -2 and a positive 20, then those are definitely going to add to be 18. So we're going to break this apart. 5n squared minus 2n plus 20n minus 8. And then we do our factoring by grouping process. And you cannot skip to the end from this step. You have to do factoring by grouping. So now we consider our first 2 and we consider our second 2. If I can get back to the problem. Here we go. Okay, so our first 2 and our second 2. So it looks like all I can pull out of the first one is an n. And be left with 5n minus 2. Now I'm doing my second set. So I can definitely pull a 2 out. I think I can pull a 4 out as well. So if I pull a 4 out, I get 5n minus 2. These match. They should. So now we do our second step, which is to pull that out again.
Wait, where did we get a 4 from again?
I pulled the 4 out of here. So if we multiply this in, we're going to get 20n minus 8,
Oh, okay.
which is this.
I'm just trying to make it simple.
So probably your biggest challenge is going to be looking at these and saying, okay, what do I pull out? And I start with the smallest number possible. So I would say, okay, well, both of these are even, so I can pull out a 2 for sure. So if I were to do this like on its own without really having the intuition that I have, 20n minus 8, I would pull a 2 out and I would say, okay, 2, 10n minus 4. I would say, wow, these are still even, so maybe I can pull another 2 out. So then I would do 2 times 2, and I would pull one more 2 out. I would end up with 5n minus 2. And that's as simple as it gets. And then I just multiply these together for 5n minus 2. So I start with the smallest number that I can think of, which is usually a 2 or a 3, and then work from there. If you don't have the intuition to do it, start small and keep working. So, okay. So we have this here. And now we do our second step, where we end up with n plus 4, which is what's left, and then what's in the parentheses. And that is our solution. And you'll notice that these guys did not end up right here, which is how this is going to work if this number is not 1. If this number is 1, these guys are always going to end up right here. But as long as it isn't, you have to do the factoring by grouping process. So, if we do something that doesn't look like one of these, something that only has 2 terms, like number 2. Correct. So if we have number 2, this doesn't look like what we've had. It doesn't look like trinomials. But we can rewrite this as a trinomial, which is all I'm going to do because you guys know how to work it. So we have 2k, actually, we have 0k squared plus 2k. Actually, you don't even have to do this. All you can do, or all you need to do, is look at it and say, huh, there's a 2 here, and I can definitely pull a 2 out of here. Do what? That's helpful. Okay, so still you can look at this and say, all right, well, I can definitely pull a 2 out of this. So if I pull a 2 out, it's going to look like this, k plus 9. And our solution here, our factors are going to be 2 and k plus 9. And our solution is going to be -9. Because what we're trying to do is make this guy true. So if we make this true, we say, okay, well, there's 2 ways that a multiplication problem can turn out to be 0. This number can be 0, or this number can be 0. Well, this number can't be 0, it's 2. And this number, it could be if we plugged in -9. So we say, okay, well, -9 will make this true. So if we have this guy here, we say, okay, how can we make this 0? This is just another example. N plus 4, 5n minus 2 equals 0. We say, okay, well, this is still a multiplication problem. So we know that one of these guys has to be negative. Well, we could plug in an n that makes this negative, and we can just kind of see that's going to be -4. Well, if we plug in -4 over here, we're not going to get 0. So we have to figure out what will give us 0 over here. So the way that we do this is we set each of these equal to 0 by themselves. N plus 4 equals 0, and 5n minus 2 equals 0. And we solve it down and we try to get n by itself. And once we have n by itself, then we know what will give us 0 for each of these. So if I do the second one, we already have a -4 for this one. So I'm going to add 2 across. Now I'm going to divide by 5. So I'm going to be left with 2/5. So these, either of these numbers, if we plug them in for n, are going to give us 0 here. So this is called the zero product property. And this is what you can do when your product equals, or when it's something times something equals 0. Okay, we will work one more and then call it quits for today.
No, let's just work the next sheet. Forget like we're gonna do factors. What was the factors?
The factors for what? It is 2 and k plus 9. Okay, so I guess we will move on to the next lesson. I doubt we will get very far on it, but we will try. 3.02.
It's only 2 problems. Oh, it's 3 problems.
This is something I can't cover in 8 minutes. We will talk about this on Wednesday, though. So do you guys want me to work one more problem or
Yeah, one more problem then.
one more problem? We did number 6.
Oh yeah, never mind.
And I'll do it again if you want, but
Man, that's wasting time.
No.
How about we do number 1?
Yeah, you can only have one problem to deal with.
Nice birthday gift, I love it. Or we could just do 2 for a whole worksheet.
Yeah, there you go. Let's go.
all right, working number 1. Okay, so we're going to deal with this like we did number 2. So we're going to look for things that we can pull out that are in common. So I'm thinking maybe 3. 3 doesn't work. 2 doesn't work. 5.
So you're going to have to do a negative, you have to do -2 times 8 or something like that.
Not necessarily. So this is called a difference of squares problem. And what it is something squared minus something squared equals 0. And this is just a special rule that I don't really know why they expect you guys to know, because they haven't gone over it yet. And if you have this, then your factors are x plus y, x minus y. So we can rewrite this as something squared minus something squared. So let's try. So we have 3a squared minus 4 squared. So my x is 3a and my 4 is my y. So now if I rewrite this down like this, I'm going to put my first number here, 3a plus 4, 3a minus 4. Difference of squares problems require a little bit of practice to recognize, but once you recognize them, they just fit this format. All you got to do is rewrite them in it, and then you can just write the answer. You don't have to go through any steps, nothing like that. The problem is looking at it and saying, this is difference of squares. So I am going to call it quits here, just to give you guys one problem to practice. So I'll let you guys go, and y'all have a good day.